All right. Well, let's see. Hmm. Oh, wow. Incredible. Wow. That's just remarkable. Amazing. Yo, hey, what's going on? Alright, Tamale. Okay. Teaching today. Make sure I understand what I'm teaching. Yeah. Yeah, most def. Yeah. Wow. Amazing. Showed up. Showed up. All right, let's get started, folks. Let's go here. Play some music. Come on in. And welcome back to class. Today's teacher's pet is GoPokes. Amazing student. Always has some of the best comments, I'm sure. Each and everything. Wonderful. And wait, what's wrong? Okay. And so class, some announcements. Announcements for you. As 5 people here. That's good. First announcement. Your homework, the next homework is due not tomorrow, but Saturday after tomorrow. So let me write that in the Discord. Next homework due Saturday, October 31. All right. And notice here, you notice right here, there's a small pumpkin. Some sort of pumpkin. Let me look at the chat here. Halloween homework? Oh, thank you, Toast. Very professorial. Actually, yeah, here, let's do a poll. Ready? Poll. Should I make the next homework due that Sunday instead? Yes? No. Alright, I'll put that poll up for 5 minutes. 5-minute poll. Start the poll. Alright. Class, look on the top of chat. Click that question. Should I make the next homework due? Click it. Options come down. Yes or no? You want me to bump it away from Halloween? Or you want to keep it on Halloween? Alright. Okay. So let's see what the chat chooses. Yo! So many professors in the chat. Shout out to Prof. Peter. Shout out to UB Math Prof. UB Math Prof. Peter's teaching Calc 2 as well. So we're sort of competing, if you'd like. But I'm not competing with UB Math Prof, who's teaching Calc 3 right now. Beautifully. Got a new outfit, BMP. Why? Why? Why do you care? Why? Did you vote? In both senses. But did you vote on our poll? Just a human? Why don't you vote? Vote again. Actually, don't. Don't do that. That's bad. Don't do that. Alright. That's funny, Professor Peter. That's a funny joke. Funny joke. Okay, that's a good one. Students, more announcements. No office hours today because there's no homework due tomorrow. And I already had an office hours on Wednesday, which I talked about, where I talked about what I intend to do for the exam on Monday. Still, there's an exam on Monday. Okay, so here we go. It's today's announcement day. No office hours today. Okay? Next office hours is on next Friday, right before, the day before the homework is due, to optimize attendance. All right. All right, so what's the subject of, what else? Okay, let me write that, let me write. There is okay, there is. Don't miss an exam. Okay. Should I make... Okay, it looks like the class... 9 of you have voted. So 9 people are going to decide? For the whole class of 30 some odd? Oh, that's because only 10 of you are here. Class. What a wonderful class I have. Yeah. Okay. we'll wait for the outcome of that poll. Okay, so class, we have 2 topics today. I gotta cover 2 topics. They're easy topics today. All right. What are they fundamentally? Fundamentally, students might have asked the question. I don't know if you've asked this question. I don't know if you've thought about this. But what if a series isn't positive? We've only been talking about positive series. What if you don't have a positive series? Have you ever wondered this? Like, what techniques do you have at your disposal? We're gonna start learning some of them, okay? So the first technique, first idea, the first concept is the divergence test. Almost, Jan. Basically, almost, yeah. The second idea is Jan's idea, basically. It's called, we're gonna study the notion of absolute convergence. Okay? So that's the, oh, is that, hold on. You want the closed captioning? Fine. Here you go. It should work now, all right? This class, man, this class. Okay, let's start with the divergence test. Let's see what it tells you. Okay, the divergence test is called the divergence test because the only conclusion it ever gives you is divergence. That's why it's called that, okay? And that's why it's red. So, first thing you need to know, the only conclusion it will ever give you is divergence. Okay? And let me tell you what it says. What the heck does this test say? Okay. Here's what it says. If you have a series, and Math Mama always asks, hey, why does this one matter? Does this matter? No. When we're talking about just convergence or divergence of a series, that starting value doesn't matter because we care about the last infinity part of the addition problem. Okay? That's why I just put a 1 there, randomly. Start adding up an infinite list. If this series has the property that the limit of the terms, meaning the individual quantities that you're adding up, if you look at that limit and it's not 0, if you have a series whose terms don't go to 0, the limit doesn't exist, the limit is 5, the limit is 0.001, all of those are examples of the limit of the terms not going to 0, not being 0. If you have a series whose terms don't go to 0, then it diverges. Okay? That's what it states. Let me tell you what it means in words. In cowboy terms. If a series has any chance My cowboy accent sucks. If series has any chance of converging, then the terms better be going to 0. Y'all. If a series has any hope of converging, the individual terms, they better be going to 0 eventually. That makes a lot of sense spiritually. What kind of math problem, infinite addition problem, has any hope of yielding a finite sum if the individual quantities aren't getting small? 0 small towards the end. That's the only time. Only then do you have a shot at converging. That's what the divergence test is saying. The divergence test stated this way is, if the limit of the terms does not go to 0, if the limit is not 0, too bad. Your series definitely diverges. Okay? Exactly. Yeah, look at this. Look at this. Look at Professor Peter. But let me do a different example. Hey, here, let me do an example. Let's check out this series. I know you could probably do all kinds of comparison tests and so on and so forth. Yeah, I get that. I get it, okay? There are 10 billion ways of doing a given math problem, all right? I understand that. You already know how to do this problem. But let me show you another reason why this series diverges. I hope you immediately felt that this series diverges. Let me tell you why. This thing diverges. Because look. Take the limit of the individual terms. And you all know how to do this limit. You know, divide out, blah, blah, blah. This is stupid, yeah? Okay, we can do this. This part goes to infinity. Sorry, this part goes to 0. And so the limit is 1. Question. Are the individual terms tending to 0? So no luck. This is what the divergence test says. No luck. Series does not converge. By the way, this makes so much sense, folks. Look, what does it mean for the terms to tend to 1? What does this 1 mean? This 1 means we're adding up a bunch of numbers. Those numbers start to look very, very, very close to 1 eventually. Wait. So you're telling me I'm adding up a bunch of numbers that are basically 1 infinitely many times? That can't possibly converge. That's just gonna explode. 1 plus 1 plus 1 plus 1. It's gonna get close to that. That's huge. That diverges. The divergence test makes sense, folks. Okay, I'll show you another one. Okay. Oh, here's an example. I'll do it straight from homework, I guess. Now let me look for one that one looks pretty good. Wow, look at this incredible series. Oh, n equals 10 to infinity. Okay, see, look at this. Hey class, Look at these followers. They are capitalized adjective on the first half, capitalized noun second half. My followers lately have been this kind of name. Suspicious. Definitely sus. They're a bunch of bots. The bots are getting me past the 1K threshold. They're not real. Anyway, look at this. Look at this sum. Incredible. Does it converge? It's not a sum with positive terms, so you don't have that technique. It doesn't have positive terms. Look at it. In fact, you might say it's alternating. It's an alternating series, one might call it. Damn. Hold on, what does the divergence test say here? Well, why don't we look at the limit? Well, look at the limit of the terms. Now, maybe some of you don't know how to do this problem. I wouldn't be surprised. The -1 to the n might be worrisome. But here, I'm going to divide out by n to the 7th on top and bottom. Just for you. Just for you. N squared will survive on the top. So look, I'm doing this. N squared survives, okay. 1 plus 1 over n to the 7. Do that right? Yeah. Okay, now let's try to crank n to infinity. One over infinity. That's 0. Hold on. Hold on. This thing is going to positive infinity. Right? So you got a bunch of fractions which are positive infinity or negative infinity. Massive fluctuation, getting bigger and bigger. You got a 1 in the denominator. 1 plus basically 0. This is tending to positive, then negative infinity. Then positive, then negative. It's like this. But wilder and wilder. Do this, everybody. Class, are you in public? Do this. It's going like this. This thing doesn't exist. Now, does not exist. Is that equal to 0? No. So the divergence test says no luck. Diverges. Okay, let me do another problem. Okay, let me do another problem. Let me do another problem. Okay. Bad. Roll. Hey class. Do you recognize this series? Class, I want to see some participation. Do you recognize this series? Jan, no Jan. It's not the geometric series, Jan. Oh. It's harmonic series. Harmonic series. Exactly. And class, what do you know about the harmonic series? That's right, Anonymous. That's right. Okay? Now, class, I'm about to send Grandma to jail, all right? Look, I'm about to send Grandma to jail. Here we go. Hey. This is one of my students. Actually, it's like about 50% of you. So one half of my students. The students. What does the divergence test say? Okay, step 1. Look at the limit of the terms. That's what my note card says. Step 2, let's do that. What's the term? You circle this thing, circle that. Okay. Now I do L'Hopital's rule or what? I don't know what my class does, okay? Whatever. I don't know. Just look at it. Look at it. This thing. 0. N goes to infinity, 1 over n goes to 0. This is just 0. Step 3. Let me read the divergence test note card. The divergence test said, if that limit is 0, my series converges. That's not what the divergence test says. The divergence test says the following. If the limit is not 0, then the series diverges. It doesn't say the opposite. It doesn't say, by the way, if the limit is 0, then it converges. That's called the contrapositive or something. It's some word. It's the wrong direction logic. If it rains, the grass will be wet. Does that mean if the grass is wet, it rained? No. Someone could have urinated there. All sorts of possibilities. Right? That's the kind of wrongness that this half of the population will definitely make this error. So you, don't be in this half. It says, if the limit is not 0, there is no hope. Diverges. It doesn't say the other half, which is what this student is doing. This student doesn't understand grammar. Got that? All right. Good. The harmonic series teaches us many lessons. Please remember the harmonic series and the grass and the urination. Everything all together. Holistic approach. Okay, good. So that's the divergence test. How do you know when to use it? Always have it ready like a tool belt. Have all the tests ready. I would go for the divergence test first when I see a series, just to check some vital signs. Is there any chance of convergence here? Well, let me look. Are the terms getting super small to 0? No? Throw this in the garbage. Diverges. Yes? Maybe it converges. Who knows? It could be either. Let's now take a different tool out and try to crack this nut. That's the process. Divergence test, try it early. And then if you don't get a conclusive result, move on to the next tests. Okay. So now I'm going to show you another toolkit. Another tool. Second tool for today. Tool number 2. Okay. Tool number 2. Tool number 2 involves a new notion. New notion. You ready for the new notion? Notion just means idea or something. New thing. You know what, students? Just okay. It's called absolute convergence. So let me tell you about this. What's the setting? Huh. You have some series. And maybe it has some positive, some negative terms. It's not positive, maybe. Maybe it is, maybe it isn't. Maybe it's all negative numbers. Maybe it's some hybrid. Any kind of series. You can do the following move. Here's a move. Go through the terms and make them positive. If they were negative number, if you saw a negative 0.3 in the 5th term, just swap it out for it's positive. Take the absolute value of the terms. Just make all the terms meaning look at this series instead. Whatever. Okay? Wait, are we allowed to do that? There's so many questions. I hear it. B-Boy is asking, wait, are we allowed to do this? Are we allowed to just change the series? Well, the answer is it depends on what it is you're trying to do. What I'm about to describe to you is an interesting hack. This hack only helps you figure out sometimes whether a series converges or not. This is the series we care about. And I'm describing a move you can make. Change to the absolute version of that series. Okay? Just do it. I'm just saying. Imagine doing that. And now I'll tell you an awesome tool. First, I'll tell you a definition. We say this series converges absolutely. If, when you swap out all the numbers for their positive versions, if this converges? So we say the original series converges absolutely if, when you swap out for this new series, which is now positive, look at it, if that thing converges. It's weird. It's a little bit weird, but let me tell you why we like this, why we make this definition. Here's the key. Key tool. If a series converges absolutely, then it originally converged. Then the original series, meaning it, if you want to give this a name, you can call it the absolute convergence principle test. I don't know. Let's call it that, or call it whatever the heck the book calls it. Okay, but I remember the content, not the name of the thing. I remember the idea. It's an interesting idea. Trade it off for this series. Why is this series possibly friendlier? This is possibly friendlier because it's a positive series. So you can use limit comparison and direct comparison and integral test. Positive series. So maybe it's easier to analyze the absolute version than the original one, which you don't have tools for. Let's see an example. Let me show you an example of this cool tool, this amazing tool in action. Let me show you an example. We don't know how to deal with this one. Let me write it out. This is a series that our techniques don't touch yet. It's not positive. Integral test doesn't work for it because it's not packed underneath the tail and sandwiched above the ground underneath the tail. Nothing, you can't it's not getting sandwiched for the positive series principles. So let's use this magic tool. This is our new toy. Let's try the new toy. Step 1. Trade for the absolute version. Let me do that for you. That's stupid. Of course, you just put absolute value bar. That's what you do. You just swap them if you have to. Okay, but that just means you're adding up these numbers. So this is the absolutification of our series. The absolutification. Is that what we call it? Well, that's what I'm going to call it. Okay? Question. Now let me look at the chat. How many people are awake? Let's look at the chat. Shrek? Oh, everyone's asking, why is it true? Why is it true? Wonderful questions. I will, after we see this example in action, I'll start talking about why it's true. Great. Wonderful, Shrek. I'll talk about that. Okay, but class. Okay, some of you are sleeping. I see Hot Tamale is sleeping, but look at this absolutification. How do you feel about it? Tell me your feelings. Tell me your feelings. What do you feel? How do you feel about that series? Is that a friend? Toaster. That's why I like this toy. I agree with you, Toaster. It's cool. I will demonstrate why it's true afterwards. Possibly seeping into Monday. Convergence. No. Hot Tamale. This is a friend. Dingy, this is a friend. This series is a friend. Go Poke says got it. Teacher's pet. Actual teacher's pet. P test. P is 2. P is bigger than 1. Exactly. What? Okay, yeah, exactly. Okay, so this is a convergent. Converges. Thin tail. And it's a bunch of Minecraft boxes underneath the 1/x squared dinosaur tail. Meaning, watch the integral test idea. Okay? Awesome. This is a dinosaur. Okay, thin tail. Awesome. So, what do we know? Our original series, so conclusion. Our original series converges absolutely. And so the new toy, the new principle, tells us. Okay? So this is beautiful. It's a good tool. It says it allowed us to tackle this alternating plus and minus hybrid type of series by magic of this new tool that Toaster is intrigued by. I traded off like a magic trick. I traded off for the positive version. The positive version converged. And so the new tool says if the series converges absolutely, then it converges. Please remember, it's an if-then statement. One way. It's a one-way street. If it rained, the grass is wet. It's not saying the opposite. It definitely is not saying the opposite. The opposite is false, as we will see next week. It's not true that if it converges, then the absolute version converges. That other direction, it's not true. If the grass is wet, doesn't mean it rained. Think of all the alternatives. Okay. Good. All right, so let me move now to that explanation. Explanation. Okay, so let me set this up real fast. What I'm going to do first is I'm going to tell you a fact about numbers that Toaster, I'm only talking to Toaster. Toaster asked. Toaster, I'm going to tell you a fact about numbers that you will never be able to deny. And then once I tell you this fact, I'll stop. And then I'll continue with the explanation on Monday. I'll leave you in suspense. Okay, Toaster. Pick a number, any number. Let's call it T. T for Toaster. Okay. Your favorite real number. Real number. Okay. I want to look at T plus its absolute value. Okay, I want to look at this number. Take a number and add its absolute value. Toaster, I claim that there are two situations. Either you chose a negative number for T. If you did that, like -5, this sum right here would be 0. Okay, so either you get 0, or if you had chosen a positive number for T, like 5, you would get double. You'd get 10 if you looked at this sum. Or you'd get 2 times that thing. Those are the only extremes, my friend. Toaster, there are 2 situations that you get when you do T plus its absolute value. It's very deep. However, I can rephrase this. I can say it I can deduce the following chain of inequalities. So, Toaster. Here's Toaster's theorem. Zero is always less than or equal to a number plus its absolute value. And that is always less than or equal to 2 times the number. This is true for any number. This is Toaster's theorem. And what we're going to do, I'm going to use Toaster's theorem plus direct comparison principle to deduce the absolute convergence test. Just for you, Toaster. I'm going to use your theorem on Monday to deduce, plus direct comparison, a previous fact, and out pops absolute convergence. Are you excited? I hope you're excited. I hope you're excited, Toaster. That's on Monday. Monday. I'll use this plus direct comparison to deduce absolute comparison. Exciting! Okay, done. Let's start credits. All right, today. Okay, someone redeemed recorder. Boring math professor wife redeemed recorder. That is an imposter. Definitely sus. Okay. You want me to juggle too? You want me to do both at the same time? What is this? Okay, well, let's do it. Let's go. Okay, I gotta find me. Alright. Okay. Okay. Students, review. I taught you 2 new tests. I'm in the middle of teaching you the second one. First one, though, the divergence principle. Review it right now as I play this recorder and juggle at the same time. Whatever. One of my favorite tunes. Okay. A 1-note samba. All right. I think I hit an octave in there somewhere. That's right. That's really challenged. All right, let's do credits. Let's roll credits, folks. Winding down. Today was a great day in this here experimental math class. In this weird experiment. We had a good day. Who gets credit? Go Pokes. Teacher's pet. Actually said something smart today. Emphasis on the actually. How do you put emphasis? Like, you put some... Is that right, Kappa? Oh, whatever. Go Pokes. Who else? Who else today? Recorder, Crow. Okay, Crow. Crow, of course, gets in due to corruption. Okay, Crow, you got in. All right, who are my Toaster? How can Toaster not be in here? What's the Toaster? Greek. Toaster's theorem. No. Toaster. Toaster's good. Toaster's good. I prefer Toaster for your name. Okay, if you don't mind. Who else? Who else is here? Battling Storm says they have 8k points. How do I spend them? Do these comments count as participation? Wait, what did the class decide? Where's the poll? Where's the poll? Okay, 6 out of 10 people voted yes. 4 voted no out of the 10 people that actually participated. folks, participation matters. So I'm gonna change it. All right. Homework is now due. All right. Look on the Discord, everyone. All right, there you go. Okay. Who else? Who else was here? Battling Storm gets in, I guess. Who else are these I guesses? There's Hot Tamale. There was, who else was in here? I gotta scroll. Hot Tamale was here. Shrek. Dude, Shrek. Shrek was just on a roll. Five head. Definitely on a roll. Shrek. I saw you in the chat. Good. Who else showed up? Class. Dingy shows up. Dingy shows up to say, let me tell you what Dingy said. I feel like I need a gin and tonic. Okay, that's what you contributed today. Contributed alcohol. Which is just, wow, amazing. All right. Anonymous Cowboy was saying a lot. Saying a lot about other professors. Or gossip. Thank you. Jan was here. Jans. You are now immortalized in the credits. Awesome. Professor Peter was here. He's a mod. Algebraically challenged. Mods. BPS. Who else? That's right. There's an announcement. Class. Oh, you're gone, but starting next week on Thursdays, don't show up. Because what you'll find is, in order to sort of, I will be doing some video recordings, and I don't want my identity to be revealed. So I will be wearing a wig on Thursdays and different glasses and stuff. It will appear to be not me. This will not look like, I will not look like my natural state. This. On Thursdays, I will be wearing a wig and making some serious sounding fancy videos. It's not, but that's what I'm doing. So if you see something weird on Thursday, just turn the screen off. Just take your laptop screen and just turn it off. Okay? So don't be alarmed on Thursdays. So yeah, just don't freak out. I'll be wearing a wig. That is not what I normally look like. All right? So once COVID is done, You go out. We're all back on campus. Look for this if you want to come see me. If you don't see this, don't say hi. Remember that. Awesome. That's right. I don't know what you're talking about. F and HC. I don't know. Yeah, just a human. Yeah, yeah, exactly. People understand. Okay. Rec. Oh, President Hargis. How do you say it? Hargis? Hargis. Credit to President Hargis. He's retiring, so much respect. Thanks for raising all that money, and it really did trickle down. Okay, so here's the credits. Ready? Go Pokes! Bro! Oster, thank you. Battlestorm Galactica. Hot Tamale, all my students. All my students. The ones that don't show up, like Kotz and Chizonin and all these, especially you. Dingy, for that contribution. Anonymous, Jans. Then Hargis, I guess. All right, good. Now go, folks. Have fun in the Discord. Contribute to the memes. Study. That's it. It's as easy as that. Stay positive. Everyone's having a hard time. You think your exam scores are low? The whole damn class has low exam scores. Don't worry. Just keep trying. All right. Keep studying. Rewatch the video. Read the book. Have fun. All right, get out of here. Let's get out of here. Yeah, what? Yeah, what? I'm late. Why are you screaming at me all the time? For what? I'm always late? Really? Oh, and you're never late. Is that... Oh. Oh, right. Oh, okay. Yeah, and you're just Miss Perfect, aren't you? Oh. Oh, I see. Okay. Oh.